Welcome, Veronica. Welcome. Hi guys.
Evening, sir.
Even
Yeah.
so,
Yeah, man. Um, Anybody has a difficulty sometimes getting using the link to come into the class? I don't know if it's my device or what.
No, I don't have any difficulty.
no,
No?
not since no. Mhm.
Okay. I don't know. When I do it from the computer, it is seamless. But I think when I do it from another device, I'm just having it, and it's one of those things. Anyhow, I had given you some stuff, Mikey. I was waiting on the follow-up stuff, the comments. Have you completed the other question? I need to move into something, a fun activity tonight, and I need to wrap off this topic. How far are we with the question that we did the last time around? Anywhere? We finished the question?
Sir, for
Has
me,
it?
I haven't gotten a chance to complete it as yet, sir.
Yeah, but all right. I particularly wanted to go through that so I can wrap up that. I really don't want to come back to it. I need to wrap up. That's why I think I'm almost sure I sent a message in the group to finish off the question while I was coming in, having a difficulty coming in. Yeah, to please finish off the question. Um, all right, we need to. Oh, you sent me something today, Mikey. No? Yeah, you sent me something. No, it's yesterday. Okay, yeah, you sent me something. That's what you sent me yesterday. All right. Um, Come on, guys. We need to finish off the work when I give you in a month. Oh, I need to finish off this stuff tonight, guys. I really need to finish off because I'm not coming back to this afterwards. There are other things to look at. So can we go and look, get your scatter plot? Mikey, I'm seeing the scatter plot. 1, 2, 3, 1, 2, 3. This looks okay. Graph showing. I like your title. I like your axis. 1, 2, 3, 1, 1, 2, 3, 1.5, 1, 2, 3, 2, 1, 2, 3, 2.5, 1, 2, 3, 3, 1, 2. All right. The x-axis seems fine. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 87, 90, 91. The y-axis seems fine. This seems okay. 2 centimeters to represent 0.5 of the unit. Hmm. Um, all right. I need to talk to you about something. Are you looking at the graph, Mike? All right, let me. Mm, 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 mm.
Yes, sir. I'm looking at it.
All right. I'm seeing an error on something here. Let me just, guys, when I give you work to do, you need to do it. Copy image. Because it's for a reason like this error now that I'm seeing that I need to address that now copying the graph, Mikey. Mm -mm. Choose. Share screen now. All right, can you all see the screen?
Yeah,
Yes,
I'm
sir.
seeing it.
All right, so, all right, and I want to, okay, so the graph is neat. We'll definitely pick up some marks. I was going to say that I would have given him full marks until I looked down at something and saw an error on the graph, and I want you to agree with me. And this is why it's important that you present the work so that I can scrutinize it. So the graph is neat. He has his title, graph showing the rate of death of plants after the application of a herbicide, right? Now he has his x-axis labeled. He has a scale on both axes, and he has a graph that is drawn. Very neatly done. Is there any pen written on this graph, Michael? I'm just checking. Somehow that looked like a blacking pen to me, Mikey. And why can't you answer, Mikey?
Oh, I thought I was there talking. Yes, sir. I saw the title in the pen, but sir, the reason why I did that, I was going to do everything in pen, but I said, maybe it wouldn't show with the pencil. But afterwards, then I realized that it's actually showing with the pencil, and then I said, I'd have to do
Yeah.
it over. Yeah.
So it is to be done. It is to be done in pencil. All right. It's to be done in pencil. But guess what? Let us go and look at this. So what he did, he went up by 5. And if you can see where his 0 is, let me spotlight so that you can all see, because we need to learn. This is his 0. He went up 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100, 105, 110. Very good. Let us look at the x-axis. Do you see anything wrong with it? Let us look here. This is 1.5. What is this? 1.5 centimeter.
1.5 centimeter.
1.3, 1.3.
Oh, that look like 5. Okay.
A 3.
1.3 centimeters, so 10 units.
Yes, sir.
So this measure 1.3?
Yeah, it actually measures 1.3.
Okay. All right, so that's fine. But when you look at this here, I'm counting that you went up by 5, 10, 15. That's fine. Anything observable with the x-axis though?
It's well, it's using three blocks instead of 2, like on the y-axis. Yeah.
Right. So 3 blocks represent what?
5 units.
3 blocks represent no. For the x-axis I'm talking.
0.5 units. So there's 3 blocks. Yeah.
3 blocks representing 0.5 unit.
Oh, I see.
What will you see, Mikey?
That's impossible.
Impossible. Because if 3 blocks is representing, that means this has to be 0.5.
5, yeah.
This is going to be what? 1.
1, yeah.
And this
I
is
see it.
1.5 and then 2. Right.
Yeah.
So when I glanced at it, I was like, oh, very neat. You'll get to, I said, hold on.
Yeah.
If 3 blocks is representing 1, that means another 3 blocks, this should have been 2. You follow what I'm saying?
Yes, sir.
Everybody see the challenge? No, I guess I don't see it.
Yes, sir.
You kind of lost me.
Yeah. So what I'm saying to you is, so his y-axis is perfect, but his x-axis, no, he uses 3 blocks, 1, 2, 3 blocks, and call the first one 1. So it therefore means that every 3 blocks will be 1 unit. But the next 3 blocks, he call it a half.
Yeah. Yeah.
And then the other one 2. So right there and then, this now nullifies this graph to be a perfectly drawn graph, because what is going to happen now is sorry, I was teaching some calculus today. Don't pay them gibberish in mind. I was teaching some calculus today and copy some stuff. So the first document I saw, just copy your stuff to it. Right. So again, Mikey, this is going to be what? This is going to be your third time now, or is it or is it yeah, you had done the graph, the scatter plot before, right? And send off to me.
Yes, the others were not on graph paper though, but this is the
Oh,
first
okay,
one
got
on
you.
graph.
Got you, got you. All right. So it is important for me to see it on the graph paper so I can know, be convinced that you know how to calibrate. Now, let me tell you why I'm being so nitpicking on this issue. Anybody having any difficulty with any of the topics that we've done so far?
Not so far.
All right.
Sir,
And
I just have one problem,
what problem?
with
And is it
this.
rounding off?
Well, no, not necessarily running off,
Okay.
When it asks for the parameter in the question, I was like, what am
Oh
I
no
supposed
no. I'm gonna go through that, man. I'm gonna go through that. Don't worry
Okay.
about it. So
That had me wicked.
what you don't see now, when I'll explain it and you see what is happening. No, that's fine. That's fine. But the point I'm trying to make though is um when you're going to school, it happens for engineering geology, it happens for the it happens for the built environment, environmental law, you name it, any course you're doing, and you are following what is happening in the course, it simply means that that or those questions are questions that you're going to be maximizing on either for the mid-semester or for the final exam. As I said before, this topic is a staple on the exam paper. So I have to make sure that I nitpick so that when you get your question for either 20 marks or 30 marks, you can pick up the whole marks. So work with me. So I need for this to be fixed. I need to see the other graphs. If you don't show me the other graphs so I can look at it and comment on it, it is going to be to your detriment because you're going to plot a graph and think that you are fine. And then you're going to end up losing marks. You're going to come out to the exam and say, yes, I passed the course. And then you come out to the exam and recognize that you get a resit or you fail the course because I'm not seeing what it is. And this is why it's very important. Very, very, very important. All right.
Sir,
Now,
so you're right. Because you see when I was when I was plotting this, the coordinates that they were it never did feel right. But I couldn't pick up on what was wrong.
Right. It was, and then again, no. So help me out here. Can you see my screen still?
Yes, sir, I've seen it.
This is a point that is supposed to be on the graph. I
Yeah,
see
man.
something.
Yeah,
Okay.
that's a point.
So what I look at, I saw your 3 points down here. So you have an even number of points on either side. So it looks at a cursory glance, it looks like the correct thing. Now, what I want you to do, and this is just a learning experience for you. What I want you to do is to replot the graph. Don't erase this. I want you to replot it and replot it correctly. And then I want you to compare both graphs and see if you see a difference.
Definitely.
Let me give you a final example on this before I move into the other questions. And I'm saying again, students, when you don't complete your questions, and then the teacher comes to class and does the question, it does not afford you an opportunity to see what it is that you can do on your own. When the teacher does it, yes, you're following, but can you do it on your own? And this is why I give you questions. And this is why I deliberately not go through the question with you last time around. The most that I did with you the last time around was a scatter plot, right? And the table, because if the table is wrong, everything else is wrong. So you have to compete. And this is not the first time. That's why I'm speaking about it. This is not the first time I would have given work and it is not completed. Please, guys, please. It's a little bit of uno. And when I put on the pen, everybody's supposed to pass the course. Remember, the program is undersubscribed. We expect students to do exam one time and come out. We don't want nobody to have to trail in a course because our courses are offered once every 2 years. That's just a reality. The last time I taught this course was 2 years ago. Right? So you have to make sure that you get through with the course. Meaning say, if you don't pass the course, if we go wait 2 more years to go to the course, we don't have time for that. We need to go try and make some money with our degree. All right, let's go. So I'm gonna look at the remaining questions on the. Okay. But then, did you write in a comment on the graph, Mike, for the graph, Mikey? When it
Yes,
says,
sir.
okay, let me hear the comment. Read the comment for me, please.
The results of the data shown as the concentration level in the herbicide increased, the rate of death also increased. Significantly, to notice is that above the concentration level of 4, they almost achieve 100% death in the plants from the plot of land use. So above 4, they experience almost 100%. You had
So
89, 90, 96%. Sorry, you're breaking up.
no man, I'm here, man. I'm here. So the x-axis is representing the what?
The x-axis is representing the concentration level, and the y is representing the percentage of death.
Death of the plant.
Yeah.
All right. So but that's one of the other things that I want you to do. So when we pick up the graph, so I see a scale.
Oh yeah, label the axis.
Label the axis as well, right?
Oh,
right. So label the, yeah, don't worry about it. And that's why you're in class. So when I point it out to you now, the errors won't be made again. So yes, so we just need to give me a minute. Let me just go for the charger for me, please. I'm not too far. Let me just so that when you look at the stuff. So yes, so I like the analysis, but there's something that jumps out at me why I spoke to you about the thing just now. Let me just plug it in and don't let me just go for something for me, please. All right, so good. So you're saying that at concentration above 4%, the effect of the herbicide will be effective, right?
Yes, sir.
Mm-hmm. All right, what I want you to do for me is to hold on to that comment. I'm going to ask you to replot the graph and see if the general shape is the same and if the comment still fits what it is that we're talking about.
Okay.
Let me tell you the importance of accuracy as it relates to graphs now. So some years ago, I had a family member who went into hospital, and they were prepping this family member for some medical treatment. What the nurse did was to come around, to take the vital signs, to take everything. They call it triage. Now, every bit of information was recorded on that graph paper. The height of the patient, the blood pressure, the temperature, every single thing. Now, as a scientist, and I want you to recognize that you guys are scientists, you guys are earth scientists. Any miscalculation from anything that you've done can cause a catastrophic event. If you're a medical scientist and the people them say supposed to give the people them a particular percentage of exposure towards radiation, and you say, sure, we could put on 5% more of it. It won't kill them. Lies. They'll be very dead. All right? As an anesthesiologist, if the calculation is off, the patient can sleep away. You kill the patient. Right? Any miscalculation, it means that your submarine will be submerged and the people them run out of oxygen. Remember that situation that happened when they had those people who were in the submarine and it just exploded?
Yeah, man, sir.
Miscalculation.
Yes, sir.
Miscalculation. So I say this, that you have to be very precise in what is being done. If you
Even the
calculate,
Columbia spaceship that exploded a couple of years ago was all because of a minor error in the calculation.
which is the point I'm making. So, a case in point, final example that I'll give, just to show the importance of accuracy. Anybody saw the United Airlines tire would drop off of the aircraft in flight?
Yep.
Okay. Okay. So it means that some ground engineer either going to lose him job and the FAA come out with them findings. Because when that plane is grounded, there are several things that ought to be checked. So it means that the nuts and bolts for that tire was not checked. And it could have been something more catastrophic that could have caused the lives of those 100 and odd people on that flight. So, you know, we need to be a little bit more careful and precise in what it is that we do. Just take a little time to do the work and do it properly. It only takes a little time for it to be a little bit more precise, because people out there have money, and people out there with money want to get more money, and they will sue your company to the ground. One of the things that people use to protect themselves right about now is something that is called liability insurance. Anybody know about that?
Yeah, man. General liability, limited liability, worker liability, employer liability, employee liability.
So one of my doctor friends studied with me on campus, now lives in the States. PharmD, she goes into the hospitals to work, she goes into the pharmacies to work, prepares prescription, apply vernal fluids, whatever the situation is, she has had to take liability insurance out because God forbid, if they say that something goes wrong, so she should not go lock up in a prison. She'll go pay her way out. She can pay her way out. Because in those neck of the wood, every single thing them sue. Every single thing. They sue. And guess what? The least little thing you go for, they may sue you. So I'm saying this again. We have to be very precise. And also, when the work give, people could do it. All right. What was the product moment correlation coefficient? You see how many marks? 7 marks to construct the scatter plot. And another 2 marks to comment on it, on this pattern. Oh, one of the things that I want to hear in the comment is there is a direct relationship between the concentration levels and the death of the plant.
There was a strong, I have that written down. There's a very strong positive relationship between the concentration level and the death of the plants.
Right. Right. Okay. What part B now? Determine the product moment correlation coefficient. For 9 marks. What is that? What you got for that?
So that's what, R. That is R? R was 0.9267.
Oh, thank you, Jesus, that you got a new calculator. Bless the Lord. Oh, thank you, Jesus. I am so happy that you have a new calculator. So yes, R is 0.92. You said 9267. I won't kill you. I'll give you full marks. Right? And with that now, I would agree with what it is that you're saying, that there is a very strong positive relationship between the bivariate variables, right? So I don't even want to use the word bivariate variables because now you know what the variables are. Concentration of the herbicide versus the death of the plant. So there's a positive relationship. So when concentration increases, the plants are getting dead. True or false?
True.
And look at what we're talking about. An area of land was taken over by an invasive piece of plant. So it is the invasive species that we're going to kill. The invasive species, pretty much we call them weed. So those are the ones that we're targeting. All right? So it says that the land was divided into plots of equal size, herbicide applied at different concentration levels. And after 2 weeks, the rate of death of plants were recorded. And the table below gives that information. So as concentration increases, more plant dead. So there's a strong positive relationship between the concentration of the herbicides and the death of the invasive species. All right. Any dissensions to what I said right there? Okay. It says to calculate and comment on the coefficient of determination. What is the coefficient of determination?
That is R square.
R squared?
Yeah, R square.
0.859.
Let me hear the comment.
Oh, there should be a comment there as well.
It says,
remember we usually.
No, we don't want to comment on R, you know.
Yeah, R.
We're not going to comment on R, right? But it says now to calculate and comment on the coefficient of determination.
Well, it's still a strong positive relationship.
Okay. All right, fair enough. That will be the value of R though. So look at how we're going to represent it in percentages now. So there's a very strong positive relationship between the herbicide applied at a different concentration level and the rate of death of the plant. All right?
Sir, that is the interpretation for
That is the interpretation for R.
For R.
For
Okay,
R.
yeah.
Right.
All right, we're on the same
So,
track.
so I am then going to pause here because you're looking for something. I am going to show you something here. I'm trying to find it. I know I have it here. Oh, giving me the question before. Oh, I'm trying to show you something here. Give me half a second, please.
So I'm gonna start to the change in the graph already.
Same way, so. Same way, so. It makes a big difference, though. It makes a big difference. All right. Coefficient of determination. I want to look at this here. I was looking back, but I recognize it. I didn't tell you before. So let me just set that straight now. All right. My coefficient of determination, 0.859 multiplied by 100 will tell me that 85.9% of the plants would die when the herbicide is applied. This is what the coefficient of determination is saying. No, don't get me wrong.
Hold
Huh?
on, sir. Hold on, sir. So to interpret the coefficient of determinants, you have to find the percentage of R squared.
You get no. What it is that you do, you're squaring R,
Mm-hmm.
and then when you square R, then you can look at R as times 100% to relate it into a percentage now. So this point,
It is similar to the Simpson species diversity index.
it could be used. It could be used, right?
It makes sense now.
Right. So what it is that you're doing, you're finding a different way to interpret what it is that you have gotten as your answer. So yes, you want to say that there is a positive relationship. How positive is this relationship? So I'm getting a little granular now. So I'm saying to you that there's a strong positive relationship between the herbicide applied at different concentration levels and the rate of death of plants, I can get a little granular now and say 86% of them invasive species will die. Does that make sense?
Yes, sir.
So
Actually,
I'm getting granular. So I'm going to say 86% of the species will eventually die now based on my coefficient of determination. So when you're interpreting your coefficient of I was going to say something to you further. The interpretation that we have here for R is still very important and needed, It's still very important and needed. So when you get the value of R, you are going to make your comment about R being that strong positive relationship. Why strong and positive? Because we go from -1 to +1. And this value here is a strong positive. This is 0.92, 0.93 if you look at 2 decimal places. But when you look at your coefficient of determination now, it is saying that 86%, 86%, 86% of them invasive species are going to die out. Does that make sense? The rest of you in the class?
Yes, sir.
Yes, sir.
Nice job. Hey, you just sneaking at the eye class and not even say good night. So, hey, I walk on.
Actually, sir, I want to disrupt your flow.
At one point in time, you weren't there, and then after that, you just appear. So, all right, good night. All right. So that is a comment on the coefficient of determination. You know how to calculate the coefficient of determination by squaring the stuff. And when you square the stuff, you're going to get another decimal place. How do you interpret that decimal place now? You times it by 100. It's 100. It's 85.6. 85.6 or 86%, 85.9 or 86%. So you can get to run and say, boy, this is effective because 86% of the invasive species now are going to meet them dead because of what it is that you'd have done. Then it says now to find the parameter and give the least squared equation. No. So if you don't know what the parameter is, do you know how to find the least squared equation?
that is when you solve for M and B.
Very good. What's the value of M?
10.86666666.
Very good. As you can see there, 10.866. It's recurring.
That's why I put the little G above it.
Yeah, it's not supposed to be a G. And I don't know why I turned a G, but yes, that's why I put this thing up here. I don't know why I turned a G. But yes, to show that the 6 recurs. I don't know why I turned a G, but must say the general, so yes, very nice. I'm happy that your calculator is repaired. Very nice. Anybody else got a 10.866? Did anybody else do the question?
Sir, I did it, but I didn't do that portion.
You didn't do that part. Okay.
I
Never
found
reached that far.
M and B.
What's the value of B?
B 39.4.
Very nice. $39.4.
Yeah. And then when you input it in the equation,
Continue.
the X value was 3.276, and I round it up to 3.3.
You lost me. What are you talking about? When you put it in the equation, you're going to get 10.8, 10.8.
Yeah, 10 times X plus 39.4. Yeah.
So what were you saying now? You put it into what?
So the 70 when I was solving the 75%.
Oh, okay, that's where you are. Okay,
Yeah.
got you.
But I'm not 100% certain that I did it right.
No problem. I'm just reading the question. If a 75% death rate is desired, what is the recommended what is the recommended concentration level of the chemical? What percent death rate did we get?
86.
86.
89.9.
86. The man them say the death rate, if a death rate is desired, what is the concentration level of the chemical? Right. 48%. The concentration of the chemical would be 48. Are you following what I'm saying?
Sir, I've been but I know the unmute button now work. All right,
Okay.
so sir, all right.
Mhm.
I thought that Y was the percentage, which would be the 75. And X would be the concentration.
Hold on then. Hold on. And that's yours. And actually, and you're correct. X is the hold on then.
So the concentration level between 75
yes.
would be
Yes.
between 3 and 4.
Yes. So it is not at the so 75 would be Y. So it would be, let me get my tablet. So there's another error with my calculation here. So 75 would be, so 75 is equal to 10.866 X plus 39.40. And I'm supposed to be solving for error.
Yeah.
Grabbing my device. I need to update my calculation. Let me just, right. So what we're having is 75% is equal to 10.866X plus 39.402. So 79 minus 39.402 is equal to 10.866X. When you divide that by 10.866, we can say X is equal to
3.276.
Nobody got that? 3 point. Um, 75 minus 39.402 equal divided by 10.866.
726.
Is it 726?
Yeah, 3.726090558.
3.276.
Yeah, 3.276 yeah.
That's not what you said though.
Oh, sorry.
Yeah, that's not what you said. But
All And then I round it up to 3.3.
3.3. And let me see something here now. Yes, I need to amend that 3.3. Hold on, let me see. All right. And let me tell you why I agree that you're running up to 1 decimal place, because all the values here given in 1 decimal place. All of these are to 1 decimal
Yeah,
place. Everybody see that?
Yes,
it
sir.
is not 3, because 3 gave us 72%. But what is happening though? 3.5 gave us only 64%.
Yeah, and 4 gave us 89.
And 4 gave us 89%.
Sir, you can go over that, please.
So by
No, this
by
is what I'm
logic,
telling you.
by logic, it would have to fall between 3 and 4.
Yes, because 3 and 4 is 72 to 89.
9, yeah.
It should be closer to 3 or closer to 4.
4, yeah.
It can't be close to 3.5. So 3.2. No, 3.3 we said.
Yes, sir.
So 3.3 would have given us the 75%. But of buff. Any questions there? You want to comment on why 3.5? Give me a hypothesis why 3.5 was only 60% effective.
Why only 3.5 was only 62% effective?
Yeah.
It could be so basically it's a piece of land that was divided up into 9 plots.
Mm-hmm.
The possibility lies that the chemical, the herbicide, was not sprayed properly.
Mm-hmm.
That's the reason why you have that low death rate in that particular area. Or there is a possibility that the
invasive species,
yeah, it was a different, the herbicide was there to kill a particular herb and not everything that was located in that plot.
Good. Or also that you never had as much, so to speak, of the invasive species within that part of the plot. Yeah, one of the 9, because we don't know which. Okay, so plot 6 and plot 4 were close. So was plot 3. So plot 3 had 2. And at plot 3, it was 66% effective. Plot 2 was 60%. Plot 6 was 64%. Plot 7 had a concentration of 89%. And plot 8,
Death of 89.
89%. Plot 8, with a concentration of 4.5, was 90%. So it could be for the invasive species, it could mean that maybe the size of the invasive species, maybe the species was was just coming up,
Sir,
maybe.
sir, we can give you another analogy.
Mm-hmm.
All right. If you look at it in with plot 5,
Mm-hmm.
3% was applied and 72% died.
Mm-hmm.
In plot 6, there has to be an environmental change why more chemical was applied and less died. So is it possible that wind could have carried the herbicide from plot 6 to plot 7 to increase the amount of death in plot 7 and reduce the amount in plot 6?
What you say, wind?
Yeah.
That could also work, yeah. What I thought you were going to say though is the soil type could have another effect on it. If it is too sandy, it may leach out and not be effective, versus it has the right consistency where the herbicide applied would have a more potent effect on the a more potent effect on the invasive species. You follow what I'm saying? Put it this way. So if I plant something in a sandy soil and I watch it, because there's so much airspace between the soil particles there, the water is just going to leach out. All the nutrients will leach out. All of the nutrients will leach out. So therefore, the herbicide will not be effective to control this invasive species.
Sure, but that would have to be the case for everybody because it's the same land.
But you don't know. Well, hold up, 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 hold up. The land is divided into different plots. We don't know. Each plot is treated differently than the other plot, because you may very well find, sometimes you may live in an area, same general area, and your neighbor gives you a planting, but when the neighbor planting them shoot, one planting, like three planting come together and are big and nice. And you say to your neighbor, say, yo, neighbor, your next door neighbor, your next door neighbor. When I say next door neighbor, the one that is immediately to your left or right, or even in front of you or behind you. Let us say behind you, and then share pretty much the same space. And when you plant it by your yard, and it shoot, and neighbor say, yes, ma'am, you can get another piece or something. And when you check a stop, you're planting them come out and little binge something. Because the soil type is different. Even though you may say, but it's the same soil with the stuff, it's different. It is treated differently.
Valid point, yeah.
Go ahead.
Valid point.
Yeah, man. No, man. I'm saying this is something that I know. I've seen it particularly with bananas and plantains. I've seen it particularly with banana and plantains. So your neighbors you live in the same general area. You expect the soil type to be the same, but guess what? My soil may be different from yours, because I may decide that I am going to do composting. So I have my stuff. I dig my hole. I bury my peels, and every now and again I rotate it, and every now and again I take up some of that because soil rich in nutrients and go throw it under the root. My neighbor may not be doing that, so my soil type is different from theirs, very different. So we don't know how each plot of land, and this is what is going to happen, or could happen. No, I'm not saying going to happen. Could happen. It's because you are doing this course of study and you'd have done levels of geography and the likes, you may be asked to hypothesize something. What could be the reason for plot 6 being 3 to the 3.5? The concentration is only 64% effective compared to plot 3 that is treated with less is more effective, right? The soil type in plot 5 may be conducive for the herbicide. Maybe conducive for the herbicide, and that herbicide may very well love that soil type. Okay, the bottom one is a new plot, or the
Yeah, it's a new plot.
but already I'm seeing something different.
Yeah, that was what I was saying. By just starting to put the coordinates, I realized that it's gonna turn out different.
Yeah.
So it has 3 on one side and 4 on the other. The line only intersects 2.
You know what is interesting? As I wanted to do this exercise with you now. Let me see if I can do it now. Yeah, so those are some of the interpretations that can come from what it is that our calculations. Those are some of the interpretations that can come from our calculation. Let me try something here. Let me do a new share and try something. See if I can do this very quickly. Are you seeing my new share?
Yes, sir. Seeing it.
All right. So based on all right, so so this is going to be this one here is going to be 1.75, comma 50. My x2 is going to be 4.5, comma 50. My y1 is going to be 4.5, comma 50. Let's share the same point. Can you see that?
Yes, sir.
I'm trying to. And up here is going to be 4.5, comma 95. All right. Watch me now. Y2 minus Y1 over X2 minus X1. Y2 is going to be 95 minus 50 over 4.5 minus 1.75. 95 minus 50 is going to be 45. And what is 4.5 minus 1.75 equal to 2.75? Oh.
2.75.
What is 45 divided by 2.75?
So 16.362.
6.364. All right. So based on this one, this is saying that the slope is equals to that. Okay, there's a slope to be 16.36. Hold on, no. We're getting the slope here to be 10.8.
10.8.
So what that says to me, Mikey, is that that is not your best. That is not the best. That is your best fit straight line, you know. But it is saying that is not the best fit straight line.
Oh.
That's what it is. So based on the calculation, our calculation is getting 10.866. And that's the value of M. M is a slope, you know. So when I calculate the slope from your best fit straight line, I'm getting 16.364. So you're off by some 6. Yeah. So even though it looks like your best fit, it means that you can get a better fit. Yes, you can get a better fit. So the least squared regression is actually calculating the actual slope of the line. The actual slope. When you do the scatter plot, you are doing it's just like an approximation, because remember what it is that I said to you is that you're eyeing what it is that you're doing. You follow me?
Yes, sir.
You're eyeing what it is that you're doing. Does that make any sense? Anybody can see the relationship with what I just calculated a while ago? To see if that make any sense?
Yeah. So you can go back to it 1 second.
Sure. So the slope that I just calculated is this slope. So you are getting your slope to be 16.364, but the actual slope is 10.
Okay.
So based on what I'm looking at, so it means say you can drop this, carry this down some more, because when If you carry that up, down, that means this go up. So if you come down a little bit more and to get the slope to be a little lower. Yeah, man. So this is what is calculated. Let me just pause in 2 minutes and I'll say something to you. So today I spoke with Mr. Walder because the Cape Math students are doing SBA, and we're doing something like, one of the students wants to do something like this for the SBA, and we wanted to get some data for when you're going to the north-south, when you're driving along the north-south highway, coast highway, you will get at different points on the highway that tells you the slope of the highway as being 6% or 4.5 or 5%. And when it gets there, it gives you a warning that if you're driving a vehicle, heavy axle, or you're carrying, something close to your maximum laden weight, that they ask you to stick to the left. All right. Now, I could possibly use some dip and strike to get the actual slope of it. And you may wonder, why is the slope important? Why is the slope important? The slope is important because of the physics of it. When you're at your maximum laden weight, chances are you may lose power in the vehicle while you're driving, and that vehicle can start run backwards. So anybody who is coming, and remember you are going down on a hill, so you lose power and you're going down on a hill, and somebody is coming up the hill, that is a catastrophic accident. I don't know if you can see what I'm creating right there. You losing power and somebody's gaining on you, that collision is going to be catastrophic. Now, let us relate this slope that is seen on the graph to what it is that we're calculating. And I'm going to put another twist to it now, Mikey. Something else just comes to mind. When you look at plot, was it plot 3, plot 6, plot 5? One of the plots that we're looking at could mean that plot 3 could be closer up here for argument's sake. That you have more of the herbicide leaching out. And the other plot. Sorry.
Oh, yeah.
Let me just see something here. You see where I'm going?
Yeah, I see exactly.
So let me just go here and show you something. Which was most effective? Plot 9.
9.
All right. Let me go back to my new share. So what I'm saying to you is that plot 9 could be right here, so. When everything is leached down here, so the weed them right here, so, would have a greater concentration because this is at the foot of the slope. You see what I'm saying?
Yes, sir.
Because there's nothing in the question I tell you that the plots are labeled in a particular sequence. So when you look at it, plot 9 has a greater concentration. The concentration increased. And you had a greater percentage of the invasive plant dying out. So chances are plot 9 could be at the foot of the hill. So everything will get washed with upper top, go down on the bottom. Nothing can live down there. So, and this also explains leaching into rivers and streams. At the bottom of it, I will get leached into the river. The top one, no chances are not get nothing, And that's why sometimes they have to build groins in order to hold the soil in place when you're on an incline. So at least when you're using your pesticides and your herbicides, at least you don't have the sort of leaching into the rivers and streams and into your groundwater reserves. So there are many things that we could get from this. And then the man them can say, how could you repair this? So how could we repair this now? So right here, so now, you could have your rivers. Right here, so you have a rivers down here and you don't want anything to get leached into the river. Chances you have to go build a groin right here. to prevent that sort of backwash into the river. We saw the math and the geography and the geology comes in play because you can actually do your calculation.
Yes, sir.
So when you go into the when next you're driving on the highway, guys, you can look at the mountains and some and any mountain at all, and you have like a house being built. That retaining wall it serves a purpose. It serves a significant purpose. So it is that you don't have that level leaching that is taking place. Because you treat your soil may not be fully treated, but the soil on the bottom, my neighbor them get, and Mikey, again, it comes back to the point. So we live in the same general area, we expect the same soil type, but because your herbicide now get leashed out of your yard into my yard, me now have a bigger planting because I don't have my planting, the roots of my planting that will compete with food because I don't have any invasive plant eating up the food that my plant's supposed to get to eat up because my herbicide is killing them all because your one is getting washed away into my yard space.
Sir, you were absolutely correct. I redid the slope
Mm-hmm.
and I got 10.
Ah, very nice. Very nice. So this is what it is. So when you do your slope now, so if when I get the calculation and I get the slope and I say, bro, whoa, how am I going to do this? And the rest of the man, them, all of the slope, we can't get all of them the same grade. If I want to be very specific now, I can just go ahead and do the slope calculation and say, here the plan. The person who gets 16, I will get 2 out of 5. And the person who get closer to the 10, we can get the 5 out of 5. Because you get 5, something like that, 5 marks or whatever it is or 9 marks, whatever it is. But yes, that's how it is done. That's how it is done. So you can go ahead and just do that practice. And what that helps you to do is to see how close you can get to eyeing what your best fit line is supposed to be. All right? I'm done with this topic. I don't know what else to say to you. I don't know what else to do. I mean, the most I can do is find some more past papers and practical questions like this, real life questions like this I can give to you. Topic done. Next class, God's willing, we're moving into some probabilities.
Hold on,
Here,
sir.
go
Go
ahead.
back to the question, quick, sir.
Go back to the question. No problem. Mm-hmm.
All right. So the section that says the perimeter of the given lease, that's which section of the calculation. I'm still not certain if I get that part correct.
Yeah, but what do you think the parameter is?
Is it solving for M and B?
Mm-hmm. Those are the
my God.
parameters.
Okay.
So the
Because they
parameters,
phrase it different.
the parameter would be the value of M, the value of B, that gives the least squared equation. So you have to put them together now to get the equation. So if you only calculate M and B is only the parameters are only fine.
Oh, that's why I didn't say 8 marks.
That's why them say 8 marks. So you need to find the parameter, and it could be parameters too. That would be the value of A and B, M and B.
Mm-hmm.
Those are the parameters. And then now the equation will be this. Putting the parameters together to get your equation. Any other questions?
Perfect, sir. Perfect.
Now hear me out. I don't know. This question could very well come back. Because in any university setting, when I was going to university, and I was studying, and the information got so overwhelming because you have handouts upon handouts upon handouts to read. And sometimes I read and hear a voice say, read no more. What next you do, you grab for your past papers and you see how the man them word the questions. Because when you answer past paper question, and this is one of the things I used to do, I used to get the past paper and go research the past paper questions. Because the research that I get for the past paper question can help me in another question, the information that is. And sometimes the question come close enough. So they may ask you to compare cassiterite with a feldspar. You may have done cassiterite from up top for something, and then you may know what a plagioclase feldspar look like down there. So, and you say, oh, but the comparison is easy. It pales into comparison. You can talk about it because you'd have done that in one of the examples. Point is, you have to grab the past paper question and do them. So when sir source these past paper questions and say, yo, work it. Don't come to class and sit down and don't do it because you're not being able to participate. And when you do the question, that's the only time you can get it to drink. My final thing for you before I release you. Something that came to mind while I was doing the question. How many of you would feel comfortable without looking back at the product moment correlation coefficient formulation and remember it?
For me,
I
not
can.
as yet. Not as yet.
Yeah. And you know why I pass? Respectfully.
More practice.
Thank you very much, sir. Congratulations, Mackie. Let me ask the other question. How many of you can, R squared is fine. How many of you can remember the formulation for M?
Yeah, man, that one day you can wake me up when I'm asleep for M and B and
And
write
B,
that.
very good. So if you don't know the formulations, you're not going to be able to go into the exam to answer the question. You can't answer the question because your formulation can be wrong. So you use a wrong formulation and you substitute the variable, your answer can be wrong because your formulation is wrong. So if you don't put practice to this stuff, remember it's not an online exam where you can go back and look at the formulas and you're not going to get the formulas in the exam. You have to remember it. That's the point I'm making. The only way you can remember it, guys, is unless you practice. You have to commit those formulas to memory. So,
Oh, sorry, your exam is not on the first draft as at the timetable.
thanks for letting me know. I need to say to them.
Yeah.
However, I know they know that we're having it because we have a vetting session on the 20th of March. And I have to drive down to the country to vet your statistics paper. And then now I'm going to get a little break the second day, and then I have to drive down again on the Friday to vet 1, 2, 3, about 4 more exam papers. So thanks for that. I'll email them to let them know it's not there. But come on, guys. As I said before, I don't want any failures for the statistics. The last iteration of it, or the first iteration of it, everybody passed it. I had 5 students doing it. And funny story, the 5 students that we had about 6 students who we had about 6 students who started. One dropped out at the end of, well, before the first semester. One dropped out. And those 5 students stuck together like matlock, stuck with it. And they all finished. All 5 of them finished at the same time. All 5 of them finished at the same time. And of all of them, it's just one student who failed one course, did a resit and passed the resit. Just one student who failed. The other 4 students passed everything the first shot. So I'm saying to you, please start studying. We have April, May, we have call it about 2 months before the semester is out. I still have more work to finish off. Just make sure that you're up to date. All right. Thanks for coming out. All the best.
All right, same to you, sir. Have a safe weekend.
To you, to Papa.
Nice, sir.
All right, cool.